Today we will program this tiny AVR microcontroller, which is called ATtiny85. And this is, I think, part 4 of my series where I explore AVR programming and essentially learn it myself and try to explain these concepts to you. But what we did in previous videos is we programmed Arduino, not actually AVR microcontroller itself, although Arduino has AVR microcontroller on top of it, 80Mega 328P. And we programmed this microcontroller using Arduino IDE. So let's do simple recap of what we did and what microcontroller is. First of all, microcontroller is a device or this small chip that will do whatever we will tell it to do. So how can we tell it what to do? Of course, we need to write code, and this code will contain special instructions that we will upload to microcontroller, and microcontroller will execute these instructions. This code will be written in some kind of programming language, and the most used programming language in microcontrollers is C. And this code, C code, we will write in some kind of integrated development environment or IDE. IDE that I used in my previous tutorials, and I think in this tutorial I will still use Arduino IDE because it contains already all the things that we need to start to program our microcontroller. And actually I will use Arduino to program microcontroller ATtiny85 in this tutorial because I don't have actual programmer, special AVR programmer, and I think you don't have it either. So let's say we wrote C code. This C code then we need to somehow transport to microcontroller. In Arduino, what we used is just USB cable. We connected to USB port of Arduino, but what we want to do is to transfer our C code that we wrote on our computer to microcontroller ATtiny85. First, what we will do is we need to translate this C code, human readable code, into machine code or zeros and ones binary code. How do we do that? In Arduino IDE, it is already done for us. That's why I want to use it. But essentially, how it is done is using special translator program, which is called AVR GCC. And essentially GCC, GNU C compiler, is special program, translator or compiler that will translate C code to machine code. But what we want to do is to translate C code into AVR machine code, which is a little bit different, but it's still GCC, machine code. So we will use program that is called AVR GCC. After we have this generated binary code or machine code, zeros and ones, we need to actually transfer these zeros and ones, these instructions, inside AVR microcontroller, which is in our case ATtiny85. How do we do that? To transfer this file, binary file, from our computer to microcontroller, first what we need to do is we need to have some kind of programmer that will transfer these binary files from our computer to microcontroller. And don't worry, this is not that complicated as it sounds, because we will use just regular USB cable and we will connect this USB cable to Arduino. Then from Arduino ports, we will have some wires, and these wires we will connect to ATtiny85. And Arduino in this case will play a role of a programmer. And I actually forgot one thing. We will also use AVR Dude, which is another program that will tell programmer to start transferring these bits, machine code, binary code, into microcontroller. And that's essentially how this transfer works from our laptop, from our PC, into microcontroller of our target. Now, what we want our microcontroller to do. Our goal today will be just to light up LED when we press a button, so that we don't actually press and hold this button and while we hold this button, LED will be on. No, what we want to do is to press button once, LED will light up and stay on until we press this button again, so that when we press it again, LED will be turned off. And yeah, that's very simple program, but it's just to show you the principle and the goal of our today's video, and essentially to try to program actual real microcontroller using Arduino as programmer. So how can we do this? If you remember our previous videos, we talked about digital input and digital outputs. So essentially what this means is that our microcontroller, its legs, they're called pins, and these pins can be either input or output. So that means if this leg is configured as input, we will actually say this in our code to make this leg input or output. So if, for example, it's input, it will quote-unquote listen to signal that will come on this pin. And it's just voltage. Which voltage will be, in our case, digital means either high voltage or low voltage, will be on that pin. And it just constantly listens to this high or low voltage level. If we configure this leg or this pin to be output, that means we will output either high level of voltage or low level of voltage. So with this said, what we want to do is we want to start programming or writing code, first of all, C code, in Arduino development environment. And again, if you remember my previous tutorials, I will not explain everything that we do in this code, because I already did it in my previous videos. So yeah, I will write code and we will see if it will work and how we will then make our Arduino to act as a programmer. Okay, so here I have setup for ATtiny85 and Arduino, and we'll program this tiny microcontroller. First, what we need to do is, of course, connect everything so that we can upload code from our laptop to Arduino through USB, and from Arduino to ATtiny85. So the way of transferring the code from Arduino to ATtiny85 will be SPI, Serial Peripheral Interface. This is just a way or communication protocol that we will use to transfer data from Arduino to ATtiny85. It is similar to USB because USB is another, if I'm not mistaken, communication protocol, and we will transfer data code from laptop to Arduino using USB, but from Arduino to ATtiny85 we will use something else because ATtiny85 doesn't have USB, doesn't understand USB. So I've asked ChatGPT to give me wiring, and it gave me this. First we connect power from Arduino's ground, and Arduino will deliver power. Arduino receives power from my laptop's USB. Ground goes to ground of ATtiny, which is pin 4, physical pin 4. And how can we find pin 1, pin 4? So pin 1 usually always in these kind of chips determined by a small tiny circle indent, how do you say it? The thing here. And semicircle tells you which direction to look. So semicircle and small tiny circle here. This will be pin 1, then 2, 3, 4. And pin 5 will be on the other side, opposite to pin 4. 5, then 6, 7, 8. And pin 8 will be actually our 5 volts power. Now, SPI lines. Arduino Nano D10 goes to ATtiny pin 1. Arduino D11 goes to pin 5, which is opposite to our ground pin, pin 4. D12 goes to pin 6. And the last one, D13, goes to pin 7. Okay, so now we connected, and Arduino will transfer all the binaries, the C code that we'll write, through these 4 wires. So the next thing, what we want to do is to actually make our Arduino be AVR programmer. So I'm taking a USB, plugging it into Arduino, and now we can go to my laptop and I'll show you how to make Arduino behave as AVR programmer. Okay, so here I have opened Arduino IDE, just empty project. And what we want to do is to go to File, Examples, and the very last one, 11, Arduino ISP. So here I have Arduino ISP. All this code, we just need to upload to Arduino. Just same as we do in every project that we upload to Arduino. So select board. I have COM7. Look up Arduino Nano here and OK. So now I click upload and we're done. So now this sketch that we just uploaded will make our Arduino be programmer. Next thing what we want to do is, because Arduino IDE was specifically written for Arduino, but not to program any other microcontrollers, like in our case 8085, we need to install some helper things, dependencies to Arduino IDE so that it can understand what we want from it. And what we want is to upload code to 8085 using Arduino that we just made to be programmer. So what we want to do is to go to File, Preferences, and here we need to open the very last option, Additional Boards Manager URLs. Click on this thing, and here we paste this thing, this link to JSON file, and of course I will leave it in the description to this video. Click OK, we will see it here, and OK to 80tiny85, which is called 80tiny core. And this package, or I don't know how to call it, maybe package 80tiny core, will help us to program 80tiny85. So now we want to open the blinking sketch, and this is just simple Arduino code that will blink LED on pin PB0 or physical pin 5 of 80tiny85, and we'll blink it. But what I want to do is to make it, let's say, 5 seconds on and only 1 second off, because I've already uploaded previous code, which is 1 second on, 1 second off, so that I can distinguish, did we actually program it. So we have this code. We need to upload this code using our Arduino Nano to 80tiny85. And how do we do that is go to Tools. We need to choose our board to where we will upload this code. And here we can see 80tiny core. This was added when we, I think, pasted the link. Here we need to find 80tiny 254585 no bootloader. So this is our board. Then Tools, again, we need to choose clock. So that means program will step through each line at some certain speed. So for example, do this first, then after maybe 1 second, 5 seconds, go to another line, and so on. And of course for LED to know when to turn on for 5 seconds and when to turn off for 1 second. Clock will be either 8 or 1. I'm not sure which one to use, because if I'm not mistaken, the default for 80tiny core is set to 1 megahertz, and this clock is internal clock. It is not crystal oscillator similar to what we have on Arduino Nano, and it's just resistor and capacitor together connected in special way so that our microcontroller knows how to count. I think we can try 1 megahertz. We just don't care about this for now. We care about uploading code to ATtiny. And the last thing, tools programmer. We use Arduino as ISP. So next step, I gotta be honest with you, I don't remember if I did this step or no, but what we need is to go to tools, burn bootloader. And this means we will apply this clock to our ATtiny 85. So either 1 or 8, and we need to burn bootloader. Okay, it says done. That means we set clock of our ATtiny to be 1 megahertz. And the last thing, we need to upload, but we are not uploading using this button because it will upload to Arduino Nano. What we need to do is go to Sketch, upload using programmer. So hit this and it says done uploading. I hope it was done. So let's just check what we have and if we did everything correctly. So let's go to my camera. Okay, so how do we test this? First of all, of course, we need to remove all the wires from Arduino. And actually I should have unplugged Arduino first to unplug power. So these wires are gone. Now we need to connect ATtiny to external power. So here I have this board that provides power from USB, and I can choose either 5 volts or 3.3 volts. We'll use 5 volts because this is what it was in the datasheet, I think, of ATtiny 85. Okay, and we need to connect our LED. So remember, it was physical pin 5, which is PB0. We connect the longest leg of LED, or positive side, anode, and negative side goes through 330 ohm resistor to ground, or minus. And these things are connected together because we have them on both sides. Okay, so I've connected to my laptop. Let's see actually if it works. Turn on. Okay. Yep, so I think it works. As you can see, we've programmed ATtiny 85 without Arduino. Sorry, with Arduino, but it works on its own. Which is really cool. I don't know. Even the blink example is very cool. Okay, so let's go back to programming our initial goal, which is press button and press again, LED will turn on. Okay, so I've connected everything again, back. On my screen right now, you can see the new code that I not write, but I asked ChatGPT. Okay, so what we have here is just going through this quickly. LED pin, same as we had, PB0, physical pin 5 on ATtiny 85, then pin 6, PB1, and then we need to set LED state because we will change its state when we press on a button. So initially it's low or off, and button state we'll set high because of the pull-up resistor, and this pull-up resistor just helps our button to behave predictably. And it's just a problem with debouncing and all this stuff. We don't care about this now. So setup, of course, we set them as output and input button with pull-up, blah, 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 and loop. So button state, we'll just read this button state, whatever we have right now, and see if we pressed it or not. Then if we pressed it, LED will be turned, actually it will flip state. So if it was on, it will go off. If it was off, it will go on. And yeah, actually turn on our LED. And at the end, we just set last button state to be actually whatever we just pressed. So just simple example, and we just want to see if it will work. So now again, we upload this code using Sketch, upload using programmer. Done uploading. So now let's go to my camera and see what will happen. So again, let's unplug Arduino. We don't need it anymore. Unplug connections, remove Arduino itself. So now what we want to do is, of course, connect our power to these power rails. So plus, minus here, and LED. Same thing to ground through resistor, but our button will go to next pin. And another thing, another pin, leg of button, go to, actually where it goes, let me check. Okay, so ChatGPT says to ground. Okay, if it says so, let's check. I don't know. So now we just need to power it and see what will happen. Okay, power up. Nothing explodes. LED is not blinking, which is good. If I press a button, all right, it works. And you can actually see even the pull-up works, which is good because you saw it. I pressed the button and it changed kind of state. So this was again pull-up through software. And what we also can do is make pull-up through hardware, which is connects capacitor to button, I think in parallel with button, so that it charges up and then gives voltage to LED, so that we don't have these spikes to button. Because again, button is a mechanical tool, mechanical thing, and inside there we have a spring that springs out, and essentially it makes contact many times. And that will be it for this video. And firstly I wanted to write the code in pure C, but in this case I'm already tired and I, to be honest, don't want to go through all the things that we already discussed in our previous videos, where I actually wrote pure C in Arduino IDE, and we did all the register manipulations. So you can actually do it on your own as a homework and see if you can do it. So yeah, and I'll see you in my next video.